Hi, for this experiment we're going to look at the rotation of a wheel. And what I have set up here is this bike on a bike rack and the Pocket Lab sensor taped to the wheel. And we'll look at the orientation of the sensor in a second. This experiment is probably more fun if you do it with a bike that you can roll around a parking lot or a street. But for the sake of this video and for talking through what you might see, we'll have a stationary bike. So here's our wheel, and this green block represents our Pocket Lab sensor here. And as we've talked through some other videos, we have 3 axes on many of our sensors on the magnetometer, the gyroscope, and the accelerometer, which correspond to the X, Y, and Z axis. And this allows us to measure three-dimensional motion. And the way I've set up Pocket Lab, here's our coordinate axes. And on the data, you always see X in red, Y in blue, and Z in green. And if we place our coordinate axes on our sensor, it looks like this, with Z coming out, X going in the radial, or sorry, the tangential direction, and Y being in the radial or direction of the spoke. And what seems like a pretty simple system will actually give you pretty interesting data. So I'll take away our diagram. Here in a sec. And we'll take a look at the data streaming live from the sensor. And the first thing we should look at is angular rotation. So that will be the most straightforward measurement. And as always with our axes, we're zoomed in so that we can see the detail of the sensor readings. And then as we gather data and we get larger magnitude signals, we'll zoom out. So if I spin this wheel, we should mostly see a z-axis rotation because we're spinning about the z-axis. So we should see in green our data coming through. And it's a pretty cool graph. You can see that there's this local or sort of smaller scale oscillation from the offset weight on the tire. And so as the Pocket Lab sensor comes around, it accelerates as it goes down. And then you can see how overall the speed of rotation of the tire decreases as we dissipate energy to friction. So you see these two trends here. And then our X and our Y rotation should be just about 0. If our axes were perfectly aligned, it should be 0. I don't know if this is what you would expect, but it's an interesting set of data that we can record. Now, what should we expect if we spin the wheel the opposite direction? Well, we know that angular rotation has a sign, and so we should, if we were experiencing positive rotation in just now, we should see a negative rotation. And so we can roll the wheel the other direction, and you can see how we get negative values. Stop it. So, interesting data from our gyroscope. Now, if we wanted to explore linear acceleration, what can we expect to see? Well, we're going to have a couple effects. One is the change in the sensor position relative to gravity. So we'll see that have an effect. And then we'll see the acceleration from the angular rotation. So if I give the wheel a spin, you can see both in the X and the Y how we have this major change as we are rotating with respect to the local gravitational field. And then if you're to look at the Y value, this is the axial value, there's an offset that changes as the speed of rotation changes. This is often called centripetal or centrifugal acceleration. So here again you can see two different trends in the data. One, this high speed change as the wheel rotates, and then in the Y acceleration you should see a decrease in the offset as our angular speed decreases. And then we'll go back again and take a look at the magnetometer data. And this is interesting because this should just give us purely positional information. So it shouldn't be compounded by the gravitational acceleration. And if we give it a spin and we move the sensor through the magnetic field associated with the Earth's field, we should see a change in our sensor reading, and that's reflected in the graph. And you should note that in all of these readings we can see this periodic nature, and it's that periodicity, the frequency and the period, change with the speed of the rotation. So spin the wheel faster, and you see those oscillations at a higher frequency. And then as our speed decreases, you'll see that trend also decrease. The frequency of our change also decreases. So here's a really easy measurement situation to set up. But there's some really interesting trends that you can see in both acceleration, angular rotation, and magnetic field. So I encourage you to tape this to one of the spokes of your bike and go to a safe place and try out different experiments. You can see how the magnetic field changes as you change your position in which direction you're biking. You can devise ways to measure the speed of the bike using any one of these sensors, the gyroscope, the accelerometer, or the magnetometer. Good luck exploring.